This is the Exam 2 test review. So we're going to start by looking at question 1. We've got some rules of exponents here. So if you want to review the rules of exponents, that's in section 12. But let's look at question A first. So if we go about this step by step, the very first thing that I would do is I would simplify inside the parentheses. So simplifying inside the parentheses, first we have 2x cubed. I'm going to bring that -1 down. So I have y to the 6th and then y to the 1st. And then from there, I will want to combine any terms that can be combined. So I have 2, and then my x cubed over x to the 4th, that becomes x to the 1st in the denominator. Y to the 6th, y to the 1st in the same place become y to the 7th also in the denominator. Okay, that's simplifying the first parentheses. I'll deal with that -1 in a second, but first I want to also simplify the inside of the second parentheses. So I'm going to bring down my x to the -4th and make it an x to the +4th by bringing it into the denominator. And then from there, I will combine the like terms. So I have 8 in the numerator. X to the 4th is x to the 5th, and y to the 8th in the numerator, y to the 3rd in the denominator becomes y to the 5th in my numerator. All right, so then after I simplify inside my parentheses, I'm going to distribute any exponents that are through, or distribute any exponents through to each parenthesis. One thing that is really troublesome is this -1 here. We don't want negatives outside our parentheses, so I'm going to get rid of that negative by flipping my fraction. That becomes x y to the 7th all over 2 to the first power, which happens to be just x y to the 7th over 2, because the first power, anything to the first power is itself. Okay, the next one, I have 8 y to the 5th, or 8y to the 5th over x to the 5th. I'm going to take all of that to the second power. So 8 to the second power is 64. Y to the 5th to the second power is y to the 10th. And x to the 5th is x to the 10th. So I have 64 y to the 10th over x to the 10th. Okay, now I'm going to combine like terms. So I have 64 divided by 2. That would give me 32. Then I have x in the numerator and x to the 10th in the denominator. So we will be left with x to the 9th in the denominator and y to the 7th, y to the 10th in the numerator. That becomes y to the 17th in the numerator. I know I am now officially finished because I have no repeats of variables throughout my expression. All the constants are reduced. There's no negative exponents and there's no parentheses. That's a good problem because it really does test all of our rules that we've looked at. Let's look at question B. Question B, I have a parenthesis that I want to reduce first. So the first thing I'm going to do is I'm going to start with this -10 over -20. 10 divided by 20 is 2, and the negatives cancel. Then I have x over x cubed, so that should give us x squared in the denominator. We probably should have brought that y up. I didn't want to rewrite a whole thing just to bring one negative y up. So if I want to bring this up, it becomes y to the 1st. So then I have y to the 4th, y to the 1st is y to the 5th. And we'll square all of that. And then we'll distribute the squared through. So y to the 5th squared, remember we multiply exponents and we square numbers. So 2 squared is 4. and x squared to the second power is x to the fourth. And there we go. All right, question 2 is going to involve different operations of polynomials that we can do. Remember that we looked at adding, subtracting, and multiplying polynomials? So let's look at this first one. We're going to perform the operation. We have 6x cubed y plus 5x squared y minus 7y plus 9x cubed y plus x squared y plus 6y. So in order to add, we are adding them. We just need to add like terms. So here we've got 12x cubed y. Then we have our x squared y's. We have 5x squared y plus 1x squared y would be 6x squared y. And then we have negative 7y plus 6y is negative y. And, okay, that's adding our polynomials. Subtracting the polynomials can be a little bit harder because we need to make sure that this subtraction goes to the entire back polynomial. That entire back polynomial is being subtracted. So the way I personally like to do it is I will rewrite my expression with that subtraction sign distributed through. So I'm going to subtract 3x to the fourth y squared. A negative times a negative becomes a positive, so that's like we're adding 5x cubed y. Same thing with the 6y. We're going to add the 6y, and we're going to subtract the 8x. So from there, we will now add like terms. We have the 5x to the fourth y squared minus the 3x to the fourth y squared. That gives us 2x to the fourth y squared. Then we have 6x cubed y plus 5x cubed y. That would give us 11x cubed y. Negative 7y plus 6y is negative y. And negative 8 minus more 8 is negative 16x. And that is our subtraction. We just combine like terms. Next, we're going to look at multiplying a single term polynomial by multiple terms. In this case, we're going to use distributing. So we're going to take that 7xy to the fifth, and we're going to distribute into each term of the polynomial. So 7 times 6 is 42. Then I have x times x squared is x cubed, y to the fifth. And then my other term would be 7 times 5 is 35. No x's to combine, so we have x, and then y to the fifth, y squared is y to the seventh. Distributing can be pretty quick and painless, so that's kind of nice. If we have one like D, where we have two terms times two terms, instead of distributing, well, it is still distributing, but we look at it as foiling or making sure that this x will multiply each term, and then that negative 3y will multiply each of the two terms. So it's like distributing two ways, or two times. So x times 2x is 2x squared. X times 5y is 5xy. Negative 3y times 2x is negative 6xy. And negative 3y plus 5y is negative 15y squared. Okay, once we distribute, we're pretty much done. The only thing is we want to look to see if there's any common terms that can be combined. In this case, we can combine the middle terms. So we've got here 2x squared minus xy minus 15y squared. So there we go. Now the bulk of what this test is going to be is actually taking this and going backwards. So being able to factor the polynomial. So let's look at question 3. That's going to be all of our different factoring questions. So remember that when we are factoring, we want to first look for a GCF and also decide how many terms our polynomial has. So in our first polynomial we're looking at, question A, we have 4 terms. So when we have 4 terms, we want to break that up into 2 and 2. So we've got the first 2 and the last 2. All right, now in each of the 2 groups, we're going to look for the GCF of the group. So between 5ax and minus 15ax, we have in 5a, I said meant 15ay. When we factor that out, we're left with x minus 3y. And in my second group, I have a positive 2b. This sign right here is going to take on whatever sign is next to the first term. So we'll factor out x minus 3y. Okay, and from there, both groups have the common factor here of x minus 3y. So because of that, we will factor out the x minus 3y. We'll write that factor out in front, and then we will write whatever's left over from each of the groups after I factor the x minus 3y out. So here I have a 5a plus a 2b. And there we go. That's our factoring when we have 4 terms. I do want to look and check and see, do either one of my factors, can they be factored further? In this case, neither one of these factors can be factored further, so we are completely finished with the problem. Okay, on question B, we have 3 terms. So if we have 3 terms, we're going to look and see, is my first term a 1 or my coefficient a 1 on my x squared? In this case it is, so this is not a terribly difficult factoring. Because of that, we're going to look for 2 things that multiply to get to this 24 and add to get to the 11. So 2 things that multiply to 24 and add to 11, looks like we would have 3 times 8, and 3 plus 8 is 11, so those are all positive. We have x plus 3, x plus 8. And there's our factoring. There was one thing I should have done very first, and that is look for a GCF. This problem didn't have one, so I didn't really think about it. And it was pretty obvious there was no greatest common factor. On question C, though, it looks like there might be a greatest common factor. So let's go ahead on C, and we have 3, 18, and 27. The GCF between those numbers would be 3. So I'm going to factor out a 3 from my entire polynomial. Okay, now from there, it's a perfect square trinomial, so if you see that, you can write it right away. But if not, let's say you don't see it, no big deal. You're just looking for 2 things that multiply to get to 9 and add to get to negative 6. So that would be negative 3 and negative 3. Negative 3 and negative 3. So that's x minus 3 times x minus 3. This is a great way to write it. If you recognized right away that it was a perfect square, we would just have x minus 3 squared. So either one of these ways to write it is perfectly fine. Okay, question D. This is a little different. There's only 2 terms, so I'm going to use my special rules. There's only 2 terms. We're going to start by looking for a greatest common factor. In this case, there is no greatest common factor, so then we're going to look and see, are my two terms perfect squares or perfect cubes? And in this case, they're both perfect squares because 25 is a perfect square, 1 is a perfect square, x squared is a perfect square. So everything in there is squared. So I'm going to use my rule. A squared minus b squared equals a plus b times a minus b. Great. So my a, or my first term, I square 5 to get to 25, and I square x to get x squared, and then my b is just going to be 1. So if I put that into the rule, I have 5x plus 1, 5x minus 1. And there we go. E is a little bit harder. We are going to want to look for a common factor on E. So let's start there. Okay, so the GCF between, let's see, we have negative 20, negative 27, and negative 9. Well, darn, there's no GCF other than a negative 1. I definitely want to bring a negative 1 out. And then here we have x squared, y, xy squared, and y cubed, so I think I can factor out a y. Okay, so that leaves us with 20x squared plus 27xy plus 9y squared. Okay, so from there, we have this polynomial right here that we want to factor. We will carry the negative y through with us in the problem, but let's look at factoring this 20. So I'm going to take the 20 and I'm going to multiply it into the 9. That gives me x squared plus 27xy plus 180 y squared. Okay, so we're going to try and find two things that multiply to get to 180 and add to get to 27. And this is going to be a little bit trickier. We're going to want to think about their signs and the multiples of 180 first. So I knew that 180 was 9 times 20. If I break that 9 up in 3 times 3 and the 20 up into 4 times 5, that might help. In fact, if you mess around with that, try pause it, see if you can get it. So go ahead and pause now. Okay, so I happened to see this 3 times 4 was 12. So if I took 12 times 15, that ends up multiplying to 180. And since their signs are the same, 12 plus 15 is 27. So we've got our factors. That would factor to, don't forget the negative y, x plus 12y, x plus 15y. Now we are not done with this problem, and that is very important to remember. We multiplied that 20, so we have to go back and divide it back out at the end. So we do that. We reduce each of the fractions. So 12 20ths reduces by 4. So 12 divided by 4 is 3. 20 divided by 4 is 5. And my second fraction reduces by 5. So that would give me 3/4 y. And then the last thing is bring our denominators up. So we've got negative y, 5x plus 3y, 4x plus 3y. And we have our factoring. I think that's one of the harder factorings that we'll see. It's pretty tricky. So if you have a different way that you like to factor these, that's fine. Okay, I'm not gonna mark you wrong if you go about factoring a different way. Okay, question F. We have two terms again, so we're gonna start by finding the GCF. Looks like the GCF between each of these is 5. So 320 divided by 5 is 64. And 135 divided by 5 is 27. Okay, now I still have two terms in what's left that I want to factor. So I am going to look at those two terms. They're both perfect cubes. Because I have y cubed, that's kind of a good clue. So I have here, the cube root of 64 is 4. The cube root of y cubed is y. And my b is, the cube root of 27 is 3. I have this rule, a cubed plus b cubed is equal to a plus b times a squared minus ab plus b squared. So if I go and put those into the formula, don't forget about your 5 out in front. That kind of gets forgotten sometimes, so don't forget that guy. Then we have a, which is 4y, plus b, which is 3. Okay, if we want to find a squared, that is 4y all squared. So that would give us 16y squared. A times b is just my 4y times 3. So that's minus 12y. And b squared is just 3 squared, so that is easy. That's just 9. And there is our factoring of our cube. This problem is the problem where you have to kind of figure out what the student is doing wrong. So my recommendation is always to just go do the problem first and then go back and look at the problem, the student's work. Okay, that one was pretty tricky because it's the cube rule, but our next one also has only two terms. And this one is a wild, wild problem. So we're going to look at giving ourselves a little more space and 256. So that is a perfect square. And I'm not sure about 6561. I believe that's a perfect square. So you'll want a calculator. Just please bring a good scientific calculator. I personally think that the calculator you can bring is going to be better than what the testing center can offer. All right, so I just square rooted on my calculator to find these numbers. So this ends up being 16x to the fourth, and here my a would, or my b would be 81. So I just square rooted 6561 and found that the square root of it is 81. So if I use my rule, a squared minus b squared equals a plus b times a minus b, and we put that into the formula, we get 16x to the fourth plus 81 and 16x to the fourth minus 81. Okay, Now, the next step is to kind of check and make sure that our factors are prime. In this case, that one is, but the second one is not. So we can factor this one further. Okay, so when I factor that further here, my a is going to be 4x squared, and our b will be 9. So we've got 16x to the fourth plus 81. That just carries down with the problem. And then our polynomial here, we're going to rewrite this factored. So rewritten factored would be 4x squared plus 9, 4x squared minus 9. Okay, and then we're just going to look one more time to make sure that all of our factors are prime. Of course they're not. Okay, that's prime. This one's prime. But this one can be factored further. So we have here our a is 2x and our b is 3. So if I rewrite this entire polynomial completely factored, we get 16x to the fourth plus 81. That carried with us. 4x squared plus 9 also comes and carries down with us. Then the one in blue can be factored further. That can be factored to 2x plus 3 and 2x minus 3. And now all of my factors are prime. With the difference of the squared rule, you have to have subtraction in between them to continue going. So that's why we could do the subtraction ones again. All right, so that personally I think is the hardest one on the test. It will have multiple things that you need to keep going on, so be careful. Okay, H. This one has 3 terms, so the first thing we want to do is look for the greatest common factor. In this case, I believe we've got a 3, an x, and a y. So we're going to factor 3xy. We're left with 2x squared minus 5x plus 3. Okay, and then from here, we're going to factor the resulting trinomial. So here we will factor that. We're going to take the 2, multiply the 3. So we've got x squared minus 5x, sorry, that's a 2, plus 6. So if we go and we factor that, that's an x minus 2, x minus 3. So we were looking for 2 things that multiplied to get to 6 and added to get to negative 5. Okay, then we're going to just divide both sides by our 2 to balance that multiplication back out. So that gives us x minus 1. And 3/2 does not reduce, so I'm going to bring that 2 up onto our x. The reason I like this method is there's not a whole lot of thinking about different combinations, which is nice. Okay, other methods that do factoring, when there's a number in front of your x squared, require you to kind of test different choices, and that can get kind of ugly. Okay, question I. On this problem, it has 4 terms, so we've got to factor by grouping. But grouping 2 to 2 is not going to work here. In fact, I see that this x squared minus 8x plus 16 has it becomes a perfect square. So I can factor this to x minus 4 squared. because 16 is a perfect square, and if I double 4, I get 8, so it's a perfect square. So I've got this factoring. Now, what I have is the difference of the squares. So with the difference of the squares, my A is going to be x minus 4, and our B is going to be 4y. So we'll just put them right into the formula. X minus 4 plus 4y, x minus 4 minus 4y. So question J, if you see the pattern here, and you kind of notice that your first term is a perfect square, and your last term is a perfect square, you can do this rule pretty quick, because if you multiply these two and double that, that's 12 times 2 is 24. This ends up being a perfect square trinomial, so we can just factor this as a perfect square and be done. Okay. The other way to do it, I'm not going to do this, but you can try, is maybe look for a common factor. There's not one. Then you can take the 16, multiply the 9, factor that, and then go from there. It's a little bit longer way to do it. So if you do recognize the perfect square trinomials, the rules are pretty quick. Those are all of our factoring that we're going to see. Some of them are not too bad, and then there are going to be a couple harder ones. You will want a calculator to test your bigger numbers. And just a little bit of advice is that if you're stuck, that's okay. Sometimes something that will help is just going and doing another problem and then coming back to it later. So if you do get stuck, don't get caught up on one problem for a long time. Come back, and then maybe once you come back, your brain will be refreshed and you'll be able to get to the answers. Okay, let's look at question 4. Okay, question 4 involves us solving for x. The previous problems were factoring, and all you needed to do was factor. In this question, it has an equal sign, so that means we are solving. We will use the factor to solve. So let's look at this first question. I have 3x squared plus 19x minus 14 equals 0. The first thing we want to do is make sure our entire polynomial equals 0. So we're good on that. Then we're going to factor. This is a little bit harder factoring. I have x squared plus 19x minus 42 equals 0. So we want to find two things that multiply to get to negative 42 and add to get to 19. In this case, it would be 21 and 2, and the 2 will be the negative one. So when we go to factor that, we get x plus 21, x minus 2 equals 0, and then don't forget to divide by the 3. So we've got x plus 7, 3x minus 2. Okay, that's the first step, is we want to do our factoring. I went kind of fast on the factoring because we just spent a lot of time doing factoring problems. You can pause it, stop it, slow down if you want to redo it or go over anything again. Okay, now there is a second step, and the second step is once we have our factoring, because it equals 0, we want to set each of our factors equal to 0 and solve for each of those factors. So in this case, to solve for this one, we subtract the 7 from both sides. We get x is negative 7. On the other one, we're going to subtract the 2 over and then divide both sides by 3. There we go. So our answers are x equals negative 7 and 2/3. Factoring is definitely the hardest part of this problem, so once you can get that down, then solving's pretty simple. And this solving is a big skill. You're going to use it for lots of applications in the future, so we need to make sure that we can factor and then solve by factoring. Okay, the next question has us, okay, it's pretty similar. This case, though, we're going to want to find the greatest common factor. So in our problem, we have 2x is our GCF. So we factor that out. We have minus 6x plus 8 equals 0. And then we're trying to find two things that multiply to get to 8 and add to get to negative 6. We get negative 2 and negative 4. It's pretty simple factoring. Okay, once we have our factoring down, okay, we want to set each of our factors equal to 0. So when is 2x equal to 0? When is x minus 2 equal to 0? And when is x minus 4 equal to 0? Well, we have here, darn, that's not working. This first one, if we divide both sides by 2, we get x equals 0. If we add the 2 here, we get x equals 2. And if we add the 4 here, we get x equals 4. There we go. So there are our answers. You can write them out individually, or you can write them together like 0, 2, 4. Either way works out just fine. As long as your answers are together and a teacher doesn't have to go looking for all your different answers throughout the whole problem. Okay, that is factoring where we're solving the equation to find the solutions. And the difference between this and the previous problems is this has an equal sign. That's the main reason that's telling us that we need to solve. All right, question 5. This is important. This is a multiple choice question. So you are going to have to match using multiple choice. That's important because you're going to have this memorized, but it's pretty simple. We have a chart here. And we're going to look at the leading coefficient. So we're going to I'm going to abbreviate that. Leading coefficient is positive, and our leading coefficient can be negative. Then our degree of our leading coefficient can either be even or odd. So when my leading coefficient is positive and I have even, I'm rising left and right. If my leading coefficient is negative and I'm even, I'm falling left and right. If my leading coefficient is positive and odd, I'm falling left, rising right. And if my leading coefficient is negative and odd, I'm rising left, falling right. So the pictures can kind of tell you the words that are happening. So we're going to look at each one of these problems. So here, there's my leading coefficient. It is negative and even. So that means that we are going to fall left and right. And you're going to match a graph, so you just need to be able to tell which graph is falling left and right. That's all you need to be able to do. On B here, there's my leading term. So this is positive and odd. So that means that we are falling left, rising right. Okay, which if you think about what a general polynomial does, that should make sense. Okay, the next one, we have this. This is positive and even exponent. So we are going to rise left and right. Okay, so that's a graph that's rising left and right. There we go. And then our last one here, negative 8x cubed. So we will be negative and odd. So we are rising left and falling right. So that's rising on the left. The negatives become positives and the positives become negatives. So I would just get an idea of how that chart works. There is another way to do it if you're stuck, and that is by taking like a big positive number and plugging it in, and a big negative number plugging in and seeing what the ends are doing. Is it going towards positive infinity or negative infinity? Okay, let's look at the next question. Okay, this one is pretty straightforward, and we've looked at examples of it in a couple different places, but this kind of puts it all together. It says a rocket is launched from the top of a hill. The equation of its trajectory is this. Um, so it's starting at the top of a hill, and then it's being launched here. Okay, and it's going to come down and it's going to hit the ground at the bottom of the hill. So that's essentially what the rocket is doing. They're first asking us, what is the height of the rocket at 6 seconds? So that just tells us when our t is 6, what is f of t? We're trying to find the height. F of t represents the height. So we can just plug 6 into the equation. And this is definitely a calculator situation. Please don't try and do this all by hand. The calculator is a fine way to do this. So I'm going to go and put that right into the calculator. And when I calculate it out, I get 336 feet. I put feet on there because I know I'm looking for the height. Okay, the next question is, what is the initial height of the rocket? So this means the initial height is when my time is 0. So if I just put 0 in for my time, it's always going to be just that value that doesn't have an x. So it's 144 feet. Just by plugging 0 in. The next thing is find f of 4. So that also will have us plug 4 into the equation. So if I go and I plug that in, okay, I used my Apple calculator, so hopefully this calculated right, but I got 400 feet. So 400 feet, or actually we don't know it's feet. It's 400 when I plug it in, but they're asking what this represents. It represents the height of the rocket at 4 seconds. So that's what that represents. So the height of the rocket at 4 seconds is 400 feet. Now, the last question, probably the most tricky question on this, is how long does it take for the rocket to hit the ground? So how long, that is our time. So we're trying to figure out our time, which is our t. Now, when it hits the ground, that's a height. In fact, it's a height of 0 feet. So we're trying to figure out the time it takes to get back to 0 feet. So we will take our equation, which would be negative 16t squared plus 128t plus 144, and we're going to set that equal to 0. And we're going to solve. Okay, so what we get is I'm going to factor the greatest common factor out. It looks like I'm going to factor negative 16 out. I get t squared. Okay, and that becomes a minus 8 because I did factor the negative out. And then 144 divided by 16. And then 144 divided by 16, yeah, that's 9. Okay, so then we're going to factor a little bit further. We have t minus 9, t plus 1 equals 0. So if we set each of our factors equal to 0, negative 16 can't be 0, so that's not anything. T minus 9 equals 0, so t equals 9. And t plus 1 equals 0, so t equals negative 1. Okay, so our possible times it takes to hit the ground is 9 seconds or negative 1 seconds. We can't have a negative time. So the rocket takes 9 seconds to hit the ground. And we're done with that. So always check your answers, make sure they make sense in the context we're solving. Okay. All right, this is a good problem because it does kind of test your knowledge of the function of a quadratic or a polynomial. Okay, and it does use the factoring and factoring to solve. Okay, let's look at the last two questions on this test review. Okay, this first one says the length of a rectangle is 3 feet longer than the width. So here I have a rectangle, I have a width, and the length is 3 feet longer than that. If the area of the rectangle is 70 square feet, what is the perimeter of the rectangle? Now we're going to ask for the perimeter because this is a multiple choice question. And if we just said what are the lengths, you could just test which ones work and then it'd be really easy. So we will ask for the perimeter. Okay, so I have my length is x and my width is x plus 3 because they tell me my length is 3 feet longer than my width. The area is length times width. So if my area is 70 and that is x times x plus 3, and I can distribute that x through. It's not in the form we want, so I do need to subtract that 70 over. Like that. And then factor. So the factors of 70 that have a difference of 3, that's 10 and 7. There we go. So we get x equals negative 10 and 7. Now one of those does not make sense. We can't have a negative distance. So we're going to go and say, okay, that one doesn't work. That means my width is 7 feet. If my width is 7 feet and my length is 3 feet longer than that, that means my length is 10 feet. Okay. Now the last thing I need to do in context of the problem is saying what's the perimeter? Well, we know we've got 7, 7, 10, 10. So that's 20, 34. So my perimeter equals 34 feet. So that's a pretty simple problem. Setting it up, just be careful. You're reading the question and it's telling you exactly what the relationships are. And then you set your variables up based off of those relationships. Okay, the next question will be pretty similar to that. We have, the next summer project is going to be making a plan for a new pool in the yard. If the area available in the yard is 88 square feet and its length is 3 feet longer than its width, what could the perimeter of the pool be? So it's pretty much the same problem. We'll look at it one more time, I guess. So we have our area. We know that this area is 88 square feet, and we know that the length is 3 feet longer than the width. So if my width is x, my length is 3 feet longer than that. My area, x times x plus 3, is equal to 88. So x squared plus 3x minus 88 equals 0. We're going to factor that into x plus 11, x minus 8. So we've got x equals negative 11, which does not work, or 8, which does. Now, so that means 8 is the width. My length is 3 feet longer than that. That's positive 11. Interesting and consistent. So if we're looking for the perimeter, we've got 8 plus 8 plus 11 plus 11. So that's 38. 38 feet. Okay. So if there is one like this, it would be a multiple choice question because you can do them pretty quick. And they're pretty formulaic on how you do it. It's just that's how it goes and you've got it. You can also kind of guess and check the sides to kind of get there. That's also a way to do it. So you don't necessarily need a quadratic equation to solve, but you can use the quadratic if you are more comfortable that way. All right, so that's our test review. Good luck studying. If you have any questions, feel free to come and ask me and we can go over that.